Hi, so this is a quick update on the progress I've made on the project so far. And so, as you can see, it's a much more refined and stable setup, but one of the first things I want to show off is this pretty nifty design I came up with to hold the lens. And so, from the previous one, I had that over there, that clamping mechanism lens holder. Biggest problem I was having was the heights weren't consistent. I mean, I should have probably seen that ahead of time, but if I keep everything at the same height, everything will be collinear. And the next thing is, for a lot of the lenses, I had trouble actually fitting them into the thing, right? It wasn't good at holding them. And so the main idea is that you have these four magnets on each side, two halves of the thing, with an inside bevel that's around 2 millimeters. That's the thinnest lens I have. And the idea is you can slot any thickness, that's an important part, any thickness of lens into here, and the system should magnetically clasp together, which will give you this pretty nice thing. And so that's what the system I've been using here. Even better, they actually magnetize together. In fact, if you notice this, it's actually two of them really close by together, which I couldn't do with that previous setup because, distances or whatever. And so another exciting thing is I'm working on a co-laminating the beam. And so the idea is the projector normally would have projected onto a screen around 6 meters away, I believe. And so by putting a super close focal length in front of it, we can kind of model it to be the light coming out of the projector is co-laminated just for now. I mean, because relative to the entire lens setup, is essentially going to focus at infinity, quote unquote. And so the idea is this one should, theoretically, these are some of the workings I came up with in the small diagram, but it should be focusing to a point of around 3 centimeters in front of it. And the second setup, I actually didn't have many copies of the same lens, so I had to make do with whatever I had. That one has a focal point of around 10 centimeters. So the idea is having a total distance of 13 centimeters. It forms an image over here at this one's focal point, and this one has a focus point 10 centimeters away, so it should theoretically be co-laminating the light. I still have to do some more calculations. It's clearly not fully co-laminating, but another cool thing is the beam splitter seems to be working. You have a image over there, and it does the same on this piece of thing here. And so, yeah. But I think the next part of the project will be to disassemble this projector and see, well, I only disassembled it one time and I actually found the UV blocking hot mirror, and so I might try and remove that and replace it with a UV pass hot mirror from Edmund Optics or Thor Labs, whichever one is cheaper. The research group thankfully has a piece of equipment that I believe can measure the intensity of UV light, and so I'll see if I can get my hands on that, measure it, maybe measure the content of UV light here, see if I actually have to buy the Edmund Optic piece of optics. Another part might be getting to the lamp was easy, but getting to the rest of the projector actually seemed pretty hard. I might have to remove the color wheel, so that, that's probably blocking a decent chunk of UV light too. It's getting kind of costly, but I'll probably also buy another set of the same optics. I think, because right now the co-lamination isn't actually that good. It does maintain the same beam diameter for a decent chunk, but it does still eventually focus. And so I think by having another set of 5 and 10 centimeter focal length lenses, I can bring the system way closer. As you can see, I'm actually losing a lot of light. The NA isn't matching. And so if I can bring this thing closer, I'll be able to probably get a much better image and not lose a bunch of the light. I also ordered a microscope objective, and so it'll be interesting to see what would happen if I just, maybe just stick it in front of here, eventually co-laminate the light, and hopefully see the image that I got on the other end. The biggest problem I'm having so far is I can't get the microscope to, I guess, quote unquote, show me the image. The entire point of this beam splitter was to see the kind of light that I'm actually getting out, but we'll see how it goes.